Welcome to This Explainer. I am so thrilled you're here today because we are going to explore something truly mind-bending. We usually think of digestion as this simple mechanical process, right? Like it just happens whenever we decide to put food in our mouths. But the research shows it is actually an elegant, incredibly time-sensitive system driven by the very light around us. So let's kick things off by exploring the fascinating, hidden biological clocks ticking away inside our bodies.
Seriously? I gotta ask you, did you know your gut bacteria have a bedtime? I know, it sounds almost like science fiction, but our microscopic residents actually work on a strict daily schedule. Now, a bacterial bedtime doesn't mean they pull up a tiny blanket and start snoring. It means they undergo massive shifts in their metabolic functions based on the time of day. They are incredibly sensitive to when you sleep, when you eat, and, get this, the specific spectrums of light you're exposed to.
So here's our roadmap for This Explainer. First, we'll look at the body's master clock. Second, bacteria on a schedule. Third, the cost of asynchrony. And finally, syncing your gut rhythm.
All right, part one, the body's master clock, setting the biological time. Let's jump in.
Meet the suprachiasmatic nucleus, or SCN. Yeah, it sounds a bit like a spell from Harry Potter, but it's actually your body's master clock located right in the hypothalamus of your brain. The SCN is beautifully synchronized by the daily cycles of light and dark. But it's not just any light. Your optic nerve is highly sensitive to short-wavelength blue light. That's the light spectrum that's totally abundant in natural daytime sunlight, and it's what tells your SCN to halt the clock, keeping you awake and alert. Conversely, longer wavelength light, like the red and amber hues of a sunset or a dim fire, well, they don't have that same disruptive effect. Understanding these different light spectrums is absolutely crucial for orchestrating the waking and sleeping rhythms of literally every single cell we have.
Looking at the big picture, it's absolutely fascinating how this all connects. Environmental light, specifically that short wavelength daylight, hits the brain's SCN, which then sends out signals to the rest of the body. The SCN dictates when we feel hungry and when we eat, and that feeding timing in turn heavily dictates how our gut microbiome behaves. It's just a gorgeous, synchronized triangle of brain, diet, and bacteria.
Now, a crucial part of this communication system is melatonin. Think of melatonin as the darkness hormone. As daylight fades in the evening and that stimulating blue light disappears, your eyes sense the shift. The absolute absence of blue light is the specific trigger that tells your SCN to ramp up melatonin production to make you sleepy. And this isn't just a signal for your brain to shut down either. It's a vital chemical cue that prepares your entire digestive tract, including your gut bacteria, for nighttime maintenance.
Moving right along to part two, bacteria on a schedule. It's time to meet your microbial shift workers.
Get ready for a staggering number, 17%. Research shows that up to 17% of our gut bacterial species undergo daily, cyclical fluctuations. Their populations literally swell and shrink based on our circadian rhythms. This means your gut is completely, fundamentally different during the day than it is at night. Your internal ecosystem literally transforms hour by hour.
To really grasp this, we gotta look at two major groups of bacteria, firmicutes and Bacteroidetes. Firmicutes are on the feeding shift. Their populations peak during the day when we're active. They are highly efficient at breaking down complex carbohydrates and extracting calories and essential nutrients from our food. They thrive on daylight and digestion. But when the sun goes down and we stop eating, the firmicutes clock out and the Bacteroidetes clock in. They take the night shift, peaking when our bodies are fasting. They aren't focused on absorbing nutrients. Instead, they do essential cleanup, repairing cellular damage and reinforcing our intestinal walls. Attempting to force the day shift workers to absorb nutrients in the middle of the night completely disrupts this delicate balance.
So here's the real kicker. While your brain relies on light to set its clock, your gut bacteria rely heavily on food. In chronobiology, an environmental cue that sets a biological clock is called a Zeitgeber, which translates to time giver. For your gut microbiome, the exact timing of your food intake is its primary Zeitgeber. Simply put, when you eat tells your microbes what time it is. It syncs the microscopic clocks in your belly to the master clock in your brain.
But guys, it gets even wilder. Scientists have discovered that specific gut bacteria, like Klebsiella aerogenes, actually have their own internal circadian clocks and respond directly to the melatonin our bodies produce. When melatonin levels rise at night, Klebsiella aerogenes increases its motility, its movement. Your bacteria are literally eavesdropping on your brain's sleep hormones to know when to start their night shift. Crazy, right? Which brings us to part three, the cost of asynchrony. Or what exactly happens when these clocks clash?
Let's walk through the cascading domino effect of bad timing. Step 1. You give your body irregular light or food cues. That means exposing your eyes to circadian disrupting blue light from your phone or TV at 1 a.m., or eating a late-night slice of pizza. Step 2. This causes an immediate alteration in your bacterial rhythms. Your shift workers get completely confused. Step 3. Because the night shift workers don't get the fast they need to do their cleanup job, you experience a breakdown of the intestinal barrier. Step 4. This lack of maintenance leads to a leaky gut, causing widespread inflammation, weakened immunity, and ironically, even poor sleep.
When you dive into the research on these bacterial groups, the impact is crystal clear. Remember our night shift workers, the bacteriophytes? Well, they stimulate the production of vital antimicrobial peptides and play a massive role in maintaining the integrity of our epithelium barrier. If you eat late at night, you disrupt their fasting shift. Losing this critical night shift compromises that protective barrier, plunging your entire body into a pro-inflammatory state.
And this leads us right into a bidirectional trap, what I call the serotonin-melatonin loop. Your gut bacteria actually help produce serotonin, which is a key precursor to melatonin. So if your gut diversity drops because of bad timing, your gut produces less serotonin and consequently less melatonin. That ruins your sleep quality. And because poor sleep weakens your immune system and disrupts your SCN's master clock, it further damages your gut microbiome. It is a profound vicious cycle.
But hey, there is incredibly good news here, beautifully summarized by the source material. Balance the gut, break through the insomnia. This is such a profoundly empowering takeaway. Fixing your sleep and fixing your digestion are, biologically speaking, the exact same battle. When you provide the right light environment and the right eating schedule to heal one, you inherently heal the other.
Okay, part 4, syncing your gut rhythm. Let's talk actionable timing.
So how do we actually fix this cycle? Here are 4 highly specific, actionable rules derived directly from the research. First up, stop eating by 8 p.m. Give your gut the solid fasting window it needs for the night shift to do its repairs. Second, cut fluids late at night to prevent sleep disruptions from bathroom trips. Third, eat your largest meals early in the day. This aligns perfectly with when your Firmicutes bacteria are highly active, maximizing optimal nutrient absorption and energy extraction. And fourth, don't skip meals, because erratic eating confuses your gut's Zeitgeber entirely.
Proper digestion requires mindful pacing. The actual physical churning movements of your stomach, the mechanical sweeps that propel food from north to south, are tied intimately to your circadian rhythm. They literally slow to a standstill after sunset. Eating late at night means food just sits there in a dark, inactive stomach, making it a perfect recipe for sluggish bowels, poor nutrient extraction, and painful acid reflux.
That's exactly why that old adage holds up so brilliantly to modern science. Breakfast like a king, dinner like a pauper. By shifting your calories to the early part of the day, you're aligning with when your stomach is most mechanically active. A sluggish nighttime stomach physically cannot extract the necessary micronutrients from a heavy dinner. Instead of being effectively absorbed, that food is just left to ferment, causing bloating and discomfort. Daytime is for harvesting, and nighttime is for resting.
I really want to bring this all together with this authoritative conclusion from the texts. A chaotic and intermittent approach to eating is totally incompatible with a healthy abdomen. Consistency is absolutely key here. Your body, your brain, and your bacteria crave predictability. They thrive on the reliable rhythms of natural light and timed nutrition.
Which leaves us with one final provocative thought. You now know that your bacteria have a bedtime. You know that turning off the blue light and stopping the late-night snacks is the key to balancing your gut, optimizing nutrient absorption, and fixing your sleep. So I've got to ask you, what time will you close your kitchen tonight? Think about it. Apply this science to your evening routine and take real control of your internal ecosystem. Thanks for joining me for this explainer.